Okay, so what we're looking at here today, oh dear. Okay, we're looking at this lesson here, radical expressions. Okay, I'm gonna make sure that I got a pencil and that we're writable. Yep, we are. Okay, so first one we're gonna look at is this a, the root of 25x squared. So what I'm gonna do first, guys, is break this up into two pieces, okay? So we're gonna say that it's the root of 25 times the root of x squared. Okay. First thing we know is that root of 25 can just turn into a 5. Okay? 5 times 5 is 25. This root of x squared, okay, the easiest way that I find to do it is to break it up into a factor tree. So x squared is x times x, okay? And then we have to look at the index. The index is the little number in here. And of course, if it's not shown, we know it's a 2. So that 2 tells us how many to circle, okay? So we're going to circle 2, which means that I can pull 1 out. So that's just 5x, and that's our final answer. Okay. Same thing with this one here. I'm going to break it up into two pieces. Let's say it's 2. I'll just create a little line here, a little division. Okay. So we know that it's going to be 2 root 45. Okay. That's going to be one part. And I'm going to put it underneath this. Well, I'll put it here. And then also we're going to have it times the root of x to the power of 6. Okay, 2 root 45, this turns into 2 root 9 times 5. Okay, and of course we can pull the 9 out and that becomes a 3. Okay, that's going to be pulled out as a 3, so then 2 times 3 is 6. So here we're going to have 6 root 5. Okay, now I just got to figure out this piece right here, the x to the 6. Of course, if I looked at that as a factor tree, it'd be 1, 2, 3, 4, 5, 6 x's. Okay, so let's put in those x's. 2, 3, 4, 5, 6. Okay, that's my factor tree of x to the power of 6. Now I look at the index. I see that the index is 2. So I'm going to circle 2. There's 2 x's there. There's 2 x's there. And there's 2 x's there. So I've got 1, 2, 3 x's left over. So my final answer, when I put this together, is going to be 6, and then x cubed for my 3 x's, root 5. Okay. Okay, let's look at this next one here. I'm just going to create a little division. And just going to get that little... Okay, so let's rewrite this. We're going to rewrite it as 2 root 12 root x cubed. Okay, so I know that 2 root 12, if I look at root 12, 12 is 4 times 3. 4 turns out to be a perfect square. Okay, so if 4 turns out to be a perfect square, I'm able to bring it out as a 2, and 2 times 2 is 4. So 2 root 12 turns into 4 root 3. Okay, x cubed turns out to be x times x times x, so 3 x's. When I look at my index, I'm allowed to bring out 2. Okay, so I've circled 2. because my index is a 2. Remember, there's a little hidden 2 right in there. So my final answer is going to be 4x root 3, and then this x is still underneath the square root because I wasn't able to pull it out because there wasn't enough x's. There was only 3, so I was only able to take out 2 of them. Okay, I'm going to show you guys a little bit of a different way to do the letters with the next one. The fourth root of c to the power of 9. Okay, so when I look at this, the fourth root of c to the power of 9. So what I'm going to do is I'm going to rewrite c to the power of 9 as c to the power of 4, c to the power of 4, c to the power of 1. Okay, and this is still c to the power of 9. It's just written in a different form. Now I know that I am allowed to pull out one c, and I can pull out a second c. So my final answer, I can't do this c, I'm not able to pull it out, but my final answer is c squared, fourth root, c. That's it. Okay. I'm going to give you guys time to do these ones on your own, and if this video goes online, you'll be able to check your answers. I'll put the key up. Okay. Take 10 minutes to do these ones on your own, and then restart the video. Okay, so now that you've restarted the video, we're going to look at the next page here. What kind of numbers cannot appear under a square root of a radical? Does this apply to all radicals? So the key idea is that we cannot square a negative. We cannot square root, a negative. Square root a negative. Okay, does it apply to all radicals? No, it doesn't apply to all radicals because if you remember, we're allowed to take the cubed root of things like negative 27, which turns out to be negative 3. Okay, so this only applies to even indexes. Okay, so what we're going to do is we're going to state restrictions for each radical. We know they can't be negative. Okay, they're allowed to be 0 and they're allowed to be greater than 0. So what we're going to say is that a cubed is greater than or equal to 0. Okay, in this case, that means that a is greater than or equal to 0. Okay. Go away, guys. Okay. Let's look at this next one. We know that this x minus 2 is greater than or equal to, go ahead. X minus 2 is greater than or equal to 0. Okay. This is just like equation solving, guys. Okay. So just pretend that this is an equal sign. We're going to add 2 to each side, meaning that x has to be greater than or equal to 2. Okay, so x could be 3, x could be 4, x could not be 1. Okay, because if x was 1, we'd have a negative value. Okay, so I'm going to take what's on the inside here for c. 3x plus 7 is greater than or equal to 0. It's in the bag upstairs where it's in the bag. I can't find it. Go look upstairs in the boot room. I hung it up there, Luke. Okay, so 3x plus 7 is greater than or equal to 0. I'm going to subtract 7 from each side. Okay, that means that 3x is greater than or equal to negative 7. And now the last step is to divide by 3. Now x is greater than or equal to -7 over 3. Okay. Just make sure that this gets in the brackets. Okay, the last one. X squared minus 3x minus 10. If you take a look at this, it might look like something from our last unit. Of course, this looks like a quadratic, okay? And you're right, it is a quadratic. So same thing, guys. We're going to have x squared minus 3x minus 10 has to be greater than or equal to 0. When you're solving these, we know that if you're solving a quadratic, you're going to have to factor it, okay? So we're going to say x minus 5 is greater than or equal to 0. And also, oh, just going to back up a second here, guys. Okay. Oops. X minus 5 times x plus 2. Okay, that's that factored form of that quadratic. X squared minus 5x plus 2x, that's minus 3x minus 10, okay, is greater than or equal to 0. From the zero property rule, we know if a times b is equal to 0, then a is equal to 0, and b is equal to 0. Do you remember this? Okay, that's true here too. So we get x minus 5 is greater than or equal to 0, and also x plus 2 is greater than or equal to 0. Okay, so from here, we know that x could be greater than or equal to 5, and x could be greater than or equal to -2. Well, let's take a look at this. Okay, so if I look at that quadratic, we know that it's going to cross here at 5 and -2. Okay, so it's going to look something like this. Okay, any value below this y-axis is actually impermissible. So all of these values down here are impermissible. We're not allowed to go there, okay? So what we could say about this is, yes, x could be greater than -5. We are not, which includes x being greater than -2. We could also say, though, that x could be in this range over here, too. So x could be less than or equal to -2, because values less than -2, which are in this area, would be permissible. You'd still get a positive value. Okay. And that's it for that.